I'm going to talk about the National Retrofit Programme. I'm also going to apologise for my voice in advance. It's on its last legs. But okay, today at SEAI we work with the government, homeowners, businesses and communities to create a cleaner energy future. Our role is to be at the heart of delivering Ireland's energy revolution, and we're driving the replacement of fossil fuel usage in all sectors and across society. So the Climate Action Plan sets out to significantly reduce our greenhouse gas emissions by 2030. And the two big targets to meet that are to upgrade 500,000 homes to a B or B2, or cost optimal equivalent, by 2030, and to install 400,000 heat pumps in existing homes by 2030. And the reason for that is because 50% of our homes have a BR rating that's a D or lower, so the bottom half of the BR scale. To date, SEAI has supported over 515,000 homes with their home energy upgrade journey. So like I said, we've got a fairly poor housing stock. A quarter of all the energy used in Ireland is consumed directly in our homes, and that's second only to transport. Households are the largest consumer of heat energy, and heating accounts for 80% of the energy that we use in our homes. So it's about 60% for space heating and 20% for water heating. And we're still heavily reliant on fossil fuels. So the National Retrofit Plan, it's got 4 pillars. So the first one is about driving demand and activity. So we want to stimulate demand by building confidence in quality, ensuring value for money, and simplifying the customer journey. The second one then is about finance and funding. To clarify the Exchequer financial commitment to residential retrofit, there's a commitment of 8 billion to 2050 from the national, or 2030 from the National Development Plan. And we introduce measures to make home energy upgrades more affordable for households. The third one then is about the supply chain, skills and standards, and we want to expand the capacity of the supply chain to the point in the last Q&A session that we don't want to be competing with new builds. We want to bring more people into the retrofit industry to be at a high level of skill and to upskill people within the industry already. And the final one then is about ensuring that the required structures and governance arrangements are in place to drive delivery. So we have 3 main delivery schemes within SEAI. There's a fourth one then that's sort of tangential to the other 3. But the first one then is the individual energy upgrades, which has been around since about 2009. And it allows people, you've got a menu of upgrades that you can choose from. So you might want to upgrade your roof insulation or your wall insulation, upgrade to a heat pump, put solar panels on your roof, or you could do all 4 of them. But it allows people to do an upgrade or get to a B2 or beyond in a sequential basis as resources allow. It's part funded by SEAI, and it allows a homeowner to manage their own project. So they engage with the registered contractor, get a quote, go ahead with the works. So they make their application, then they ultimately pay for the works and draw the grant back from SEAI within 4 to 6 weeks. The second one then is relatively new. It's the one-stop shop service. And it's a complete home energy upgrade solution with multiple energy upgrades. So you're typically talking about, say, wall insulation, roof insulation, new windows, putting in a heat pump, mechanical ventilation, air tightness works, that kind of thing. It's part funded by SEAI, and it's fully managed by the homeowner, or for the homeowner by the one-stop shop. So it's kind of taken them from the whole way through, from the assessment at the start, to planning the works, to getting the works done, to getting the BR. And the homeowner pays for the works net of the grant amount. So I think typically for your 120 square metre, 3-bed semi-D, the costs of the works, the total cost of the works would be about €60,000 for the energy works. The grant amounts typically would be of the order of 25,000. So the homeowner is only paying 35,000. They don't pay the 60 and draw down the 25 at the end of it. So they're paying the net amount. And to do that, they have to achieve a B2 and achieve a minimum uplift of 100 kilowatt hours per metre squared per year. And what that means is like typically a D1 up to a B2 will get you that uplift. The third one then is the fully funded energy upgrades, which was mentioned by Mark previously, the previously known as the Warmer Home Scheme, and that's for homeowners in receipt of the certain welfare payments. So the people at most risk of fuel poverty. It's fully funded and managed by SEAI, and what happens is that we send out, after the application comes in and is approved, we send someone out to do a home survey. They put together a package of works that has to be delivered for the house, and then the work is allocated to a contractor who's on a panel that's gone through a full tendering process. And then the work is done, and the BR is published at the end of it. So the last one then is the Community Energy Grant, and it's sort of tangential. It's the grants, the application and projects are typically a mix of residential, public buildings, private sector buildings, community buildings, and its residential grants are in line with the one-stop shop. But there's only about 600 homes were done last year, so it's a small proportion of what we're doing. So in terms of the numbers of what we are actually doing, in 2023, There was over 67,400 applications processed, up 35% year on year. There were over 47,900 home energy upgrades, which is up 76% year on year. There were 17,600 B2 upgrades completed, which is up 108% year on year. 5,900 fully funded energy upgrades for low-income households, which is up 33% year on year, and a capital expenditure of just shy of 320 million, which is up 70% year on year. So in terms of the progress and the kilotons of CO2 saved and gigawatt hours saved, you can see in 2022 is about 42 kilotons of CO2 saved, and that went up to 73 kilotons of CO2 saved in 2023. And it's about 140 gigawatt hours saved in 22, up to 240 gigawatt hours saved in 2023. So there's fairly significant improvements year on year. We've also had the mid-year report published for the first half of 2024. We've over 31,500 applications being processed across all schemes, which is unchanged from the same period in 2023. But what we're seeing is that those applications, there's a high proportion are translating more into or following through with the works. So we've over 25,750 home energy upgrades, which is up 18% over the same period in 2023. 10,150 homes are upgraded to B2 or higher, which is up 34%. 3,300 fully funded energy upgrades for low-income households, which is up 41% on the same period. And expenditure across all schemes mid-year was 186 million, which is up 44% on the same period in 2023. Now, just to talk about the one-stop shops, give people an idea of what that upgrade looks like. So the average starting point for all the houses in the one-stop shop would be an E1, and the average post-works rating would be an A2. And often it's just because I know that the target is to get to a B2, and often when you do a lot of the installation works, you get to a certain point, and when you're replacing a boiler that's maybe 60 or 70% efficient with a heat pump that's 300% efficient or more, it just catapults it beyond. And often people actually want to get to an A rating at the end. They like that kind of the status of having an A rated house, so they aim for that at the starting point. But typically one house has emissions, CO2 emissions of 77 kilograms of CO2 per meter square per year, and an A2 house has 7 kilograms of CO2 per meter square per year, which is 91% reduction in CO2 emitted. In terms of energy use, it's 320 kilowatt hours per meter square per year, and that's an 88% reduction to get to an A2, which is 40 kilowatt hours per meter square per year. So there are significant changes and benefits to the environment from going through the one-stop shop program. It's not without its challenges. There's lots of those. There are some opportunities that we're getting through at the minute. So the big one, decarbonisation of heat is where we're going to see our biggest. It's central to meeting our emissions reduction targets. The uptake is not where it needs to be. There's lots of reasons for that, and more that I've accounted for here. There's a lack of awareness, and there's lots of misconceptions being peddled about why people don't actually why the uptake is low. Sorry, things like they don't work in new houses, or they only work in new houses, I should say. That's not true. You have to dig up your floors, put in underfloor heating. That's not true. They don't work if it's cold. That's not true. So there's lots of these things being peddled around, misinformation, right? Even just like Chinese whispers gets bandied around, and people just pick up the wrong ideas. The price of electricity is also the fact that it's spiked so highly in the last couple of years. That's been had a big impact as well. I mean, I was looking at my own bills in June 2021. It was 16 cents a kilowatt hour. In October 22, it was 42 cents a kilowatt hour. So that kind of jump has had a massive impact on the running costs and the uncertainty people have around the running costs of heat pumps. And supply chain shortages as well. When you've got a small supply chain of heat pump installers, it slows things down, then people can't get installation sooner, so they might just go, look, I'll get a new boiler. It also means it can have an impact on the price as well. When you've got someone that's in a lot of demand, they'll bump up the prices. But one of the areas where we have opportunities, we're moving away from, we're looking at some of the research we have in terms of performance of heat pumps, and we can relax some of the rules we have around the need to insulate to a higher degree for heat pumps to get a high performance. So we're widening accessibility, meaning more people can avail of a heat pump without having to do more retrofit work. We also have a traditional homes pilot on the back of Department of Housing guidance on improving the energy efficiency in traditional buildings. So it allows us to understand the technical aspects of materials, products, and associated costs, and compliance with Part E to building regulations, but how it supports us in meeting our climate action plan targets is there's 250,000 homes there now that we couldn't currently address, and through this pilot, we can start generating some real savings in those. I took an example of these built-to-last case studies that are on the Dublin City Council website. And again, it's like a really small subset of about 7 or 8 houses. But if you take the average pre-works BER of those houses, it was an F. And the average post-works was a C2. Now, okay, it's not a B2, but you're still saving 213 kilowatt hours per metre squared by that upgrade. You're saving 56 kilograms of CO2 per metre squared. And overall, you're saving more than 30,000 kilowatt hours and nearly 8 tonnes of CO2 per year for each of those houses. So there are significant benefits by bringing those into the mix and being able to address those through our schemes. And retrofit also as well, it's more beneficial in terms of the whole life cycle carbon to retrofit those houses than to demolish them and rebuild. It would be remiss of me not to talk at a national air event to talk about indoor air quality and some of the work we're doing on air quality. It's primarily around ventilation. A lot of people, actually not enough people realise that it's about providing fresh air for a healthy, comfortable home. It removes moisture, it removes indoor air pollutants, things like particulate matter, radon, nitrogen dioxide, formaldehyde, and fundamentally, good ventilation is about good indoor air quality. Like I said, we've got ambitious climate action plan targets of 500,000 homes to upgrade to a B2, but we do understand that there's a potential impact of retrofit on ventilation and indoor air quality. There was a study funded through the EPA STRIVE programme back in 2015, 2016 that looked at some shallow retrofits and found that the retrofits could have a negative impact on the ventilation rate throughout the house, and that consequently had a slight increase on the indoor air pollutants in the house. So it's crucial for us that improving the energy efficiency of our homes and making them healthier must go hand in hand. So we're funding a lot of research through our RD&D programme, about 1.4 million in funding and ongoing research, looking at things like the impact of different ventilation systems, whether it be mechanical ventilation or natural ventilation. How do those impact indoor air quality? How do they compare against each other? Occupant behaviour in houses, because that can trump any system. Awareness around the importance of ventilation and trying to get people not to be blocking vents. And just the last slide then, we're doing a lot of work with the EPA, Alison Dowdall and Aisling O'Connor on furthering radon knowledge. So the first part of that is the National Radon Survey happened this year, and there's a lot of houses got radon monitors. And if we're looking to provide the dwelling characteristics of those houses that are monitored to try and see if we can learn anything about different characteristics of the buildings that might impact the indoor concentrations of radon. So things like, well, obviously the pre and post 98 building regulations are having radon barriers in houses at high radon areas. But things like the building construction, the type of ventilation, the house, and different things like that, and how they might potentially be influencing indoor radon concentrations. We're also looking to develop a pilot in an area in Cork, because of the high prevalence of high radon in Cork, to look at, through the one-stop shop, if we can measure radon before the retrofit happened and measure radon after, and see can we determine any impact and how it might, how radon might, or retrofit might be affecting the radon levels in houses. And that would complement the EPA-funded INFORM project, which looks at modelling outcomes as well as the health and economic impact. And just the last thing to say is tomorrow is European Radon Day, so check out on the EPA socials or the European Radon Association. It's really important to try and raise awareness about radon in houses. There's 350 cases of lung cancer every year in Ireland that are directly associated with radon exposure, so it's important that we try and raise awareness of that. And that's it from me.